and the unit for that for charge is coulombs. Now we need to find individually the voltage across capacitor 1 and across capacitor 2. So first we write as the voltage across capacitor 1, which is 10 farads. And how do you find that? So again put the same formula, Q is equal to C times V. And you know your C is 10 and your voltage is the one that you need to find, and Q is 165. So you get your V now. Which is 17 volts. And this is your V1 because it is across capacitor 1. Now let's look at, so always put it clearly like this. So V1 across capacitor 1, and now we need to find voltage across capacitor 2. So you name it as V2, voltage 2, and that capacitor 2's value is 5 farads. Again the same formula, so it's going to be Q is the same, so it's going to be 165, and then the C1 is 5 farads, and you don't know the voltage. So now you keep the, now you keep the voltage as the subject, and then you find out your answer. So it's going to be 33 volts. So that's your V2. So if you're drawing the diagram, it's going to be like this. So this is your capacitor 1, and this is your capacitor 2. I think I should draw it. Okay, yeah, I think I should just write it on top so you get more space. C2, and then you just connect it, and then I'm going to put in red, which is voltage 1 across capacitor 1, and then voltage 2 across capacitor 2, and this total voltage that is coming from the power supply is 50 volts. So you saw that the voltage 1 is 17 and voltage 2 is 33. So I'm going to write here 33 volts and here 17 volts. So you already know V total is equal to V1 plus V2, which means it's going to be 17 plus 33, and that's, so V total is 50. So now you saw that the equation is balanced because V total is equal to the sum of individual voltages across capacitor 1 and then across capacitor 2. So 50 is equal to 50, which means it is right. Now similarly you need to find the same for a parallel connection. So this is for series. Now looking into parallel connection. So when you look into parallel connection, so when you draw the diagram, you will see that both capacitors C1 and C2 are connected parallelly. And you know, in a parallel connection, just like resistors in series and parallel, the voltage is going to be same. So V total is going to be equal to V1 equal to V2. But what's the formula again for parallel? It's just the opposite of resistors in series. So C total is going to be equal to C1 plus C2. That's the effective capacitance. Okay, so now let's look at what's the voltage across, which we already wrote. So that's going to be voltage 1 across voltage 2, all are going to be 50. So it's going to be 50 here and 50 here. That's it. Now moving on to the 9th question. Evaluate the circuit shown below to determine the total capacitance and then the charge and voltage across each capacitor. So as you see, the equivalent capacitor for this one is using this formula, which is 1 divided by C total is equal to 1 divided by C1 plus 1 divided by C2. And you get your answer as C total as 2 microfarad. Okay, so when you draw this into a new circuit, it's going to look like this. Just so it's just going to be one equivalent capacitor, which is 2 microfarad. And then even for the next one, it's the same. You just use the formula 1 divided by C total is equal to 1 divided by C1 plus 1 divided by C2. C1 and C2 is 4. So it's going to be again 2 microfarad. And then you have your voltage, which is going to be 20 volt. So as you know, in a parallel circuit, when the total voltage is 20 volt, it's going to be the same across these two terminals and these two terminals. So it's going to be 20 here and here, and we have solved this two capacitors into one total equivalent effective these two capacitors into one total effective capacitor, which is this one. Now you need to find, once you found the C total for both the branches, which is 2 and 2, now it's asking you to find the charge and voltage across each capacitor. So we know the voltage is going to be 20 here and 20 here, but we need to find the charge. Okay, so now you saw that it's 20 microfarad for each. Yes, we saw that voltage across parallel connection, which is this one, is 20. Okay, but that was for the effective capacitance. But what about when capacitors are in series? So you know the rule for series is going to be different, right? So this is going to be for voltage across this capacitor, and this one is voltage across this capacitor. And we know that it is, since the value is same, so it's automatically going to be shared. So 20, which is 20 here, is going to be shared as 10 and 10. Similarly here, it's going to be shared as 10 and 10. So it's going to be 10 voltage. Now if you're doing the formula before that, what we would do is first we need to find charge. So you know that Q is equal to C times V. And what is the C? Two microfarad. And what is the voltage? 20 volts. And your Q is going to be equal to 40 microcoulombs, because I didn't change this, so it's going to stay as it is. So this is your charge. Now once you got your charge, which is Q is equal to, we saw that it's 40 microcoulombs. Now, like I said, how do you prove this if this were of different values? So what you do is voltage across 4 microfarads for this branch, the first one. So it's going to be V is again the same formula, Q is equal to C times V. So when you rearrange, because you know the Q's value which is 40 microcoulomb and you don't know the voltage because that's what we are finding, and then you know the capacitance which is 4 microfarad. So voltage is equal to automatically 40 divided by 4. Yes, so that's going to be 10 volts. So since we know all the 4 capacitors are same value, so automatically the voltage shared in this branch across both the resistor is going to be 10. So 10 plus 10 gives you equal to 20 volt, and here also same, 10 plus 10 gives you 20 volt. But if in case you have a different value, then you have to find across all the 4 capacitors. So that's finished, and you have found charge and voltages across series and parallel circuit. Now looking at this circuit for the 10th question, it's asking you to determine the effective capacitance and then the charge and voltage across each of the capacitors. So let's see how we do that. Okay, so first we need to find the voltage across these 2 points is definitely 100 volt because this is in parallel branch. And here, now once again, how do you understand if this is a parallel circuit? Always look into the current flowing direction. So if you see here, the current flows from positive terminal of the battery and then reaches at this point and then splits into 2 different current. So I total is going to split as I1 over here and then here as I2. So this is I2, and then when here it comes as I2 and here it comes as I1. So at this junction you can see that I1 and I2 meets together, which is actually equal to I total, and that comes back into the negative terminal of the battery. So this is just for explanation. Yes, but now coming back to the question, how do you find the effective capacitance, charge and the voltage across each capacitor? So coming back to that, you see here, first we need to solve this branch and make it as one equivalent resistance. So again, remember series one, how do you do it? It's going to be equal to, I'm going to write it here, 1 divided by C total is equal to 1 divided by C1 plus 1 divided by C2 plus 1 divided by C3. So when you put the value, it's going to be 1 divided by 6 plus 1 divided by 6 plus 1 divided by 6, and you get your C total. So you know that you have 2 capacitors here, and once you find the answer, you're going to get 2 microfarad, and then your equivalent capacitor is 2 microfarads here. So you have solved this 3 individual capacitors into one combined equivalent capacitor, and now the voltage across these 2 junction is 100 volt and these 2 junction is 100 volt. But now we need to find what is across these 2 junction, these 2 points.